Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder your component in Vero board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin coated Vero board for your prototyping. Now we'll interface this relay with microcontroller using supporting components, that is transistors, diodes and snubber networks. Before interfacing this relay with microcontroller, we'll go through the datasheet of this relay to find out different properties and pin configuration of this relay. Here we can see the datasheet of the relay, that is HRS4H relay, and the relay that we are using in our prototype is a 12 volt DC relay. And here we can see we are using this model, that is HRS4HS 12 volt DC. Coil voltages are 12 volt. Coil resistance is 400 ohm and minimum coil operating voltages are 8.4 volt. And if the relay will be energized, the minimum voltages to release the contacts are 1.20 volt and the power consumption is 360 milliwatt. Now we can calculate the coil current of this relay using this parameter, that is 360 milliwatt. We will divide 360 milliwatt by 12 volt. So here we can check the coil current of this relay is 30 milliampere. From the schematic we can check that we are using a transistor, that is C828, to energize this relay. Because the coil current of this relay is 30 milliampere and microcontroller can handle the current maximum up to 20 milliampere, and the maximum voltages that can be handled by this microcontroller is 5 volt, and the coil voltage of the relay which we are using in our prototype is 12 volt. That's why we are using transistors. Here we can find the pin configuration of this relay from the bottom side. Here we can see the coil connections very near to the common point, and here we can see the upper contact is normally open contact and the lower contact is normally closed contact. Here we can see the bottom view of the relay which we are using in our prototype. Here we have the common point of this relay, and here are two pins for the coil, and this pin of the relay is normally open contact and this pin is normally closed contact. Now we'll use this relay in our prototype as per contacts. We will use these two pins, that is common point and normally open point of this relay in our prototype. As we can see, the distance of the common pin is not as per the holes of the Vero board, so we'll bend this pin to insert this relay into the Vero board. Now we can insert this relay in Vero board easily. We will solder this relay in circuit in the upper right corner of the Vero board. Here we have inserted the relay in Vero board. Now we'll solder the pins of this relay in our circuit. Here we have soldered the coil connection, normally closed and normally open points of this relay in Vero board. Now we'll solder the common point of this relay in Vero board. For this we'll use this pin, which is a cutting end of a resistor. Here we have inserted this pin in the Vero board. Now we'll solder this pin with the common pin of the relay. And now we'll check the continuity of the common pin with the normally open and normally closed connection of the relay. Here we have the common pin, and here we have normally closed connection, and here we have normally open connection, and here we can find two connections of the coil. We can check the resistance of these 2 points. Here we can check the resistance of the coil is 408 ohm. Now we'll complete our circuit. As we can check from the schematic that one end of the coil is connected with 12 volt. And here we can find from the schematic that pin number 10 of this ULN2803 IC is connected with 12 volt. So we'll apply 12 volt to the coil of this relay from this point. And here from the schematic diagram we can see that pin number 10 of ULN2803 is connected with 12 volt. And now we'll apply 12 volt DC to the coil of this relay from pin number 10 of ULN2803. For this we'll use wrapping wire. Here we have connected 12 volt to the coil of this relay. Now we'll connect the second end of this coil with the transistor. Here we have C8 to 8 transistor. It is an NPN transistor. The rightmost pin is base, center pin is collector, and the leftmost pin is emitter. Now we'll solder this transistor in our circuit. Here we have soldered the transistor in Vero board. Now we'll connect the collector of the transistor to the second end of the coil. Now we'll connect the emitter of this transistor with ground, and here we can check we have ground point at this end of the switch. Now we'll connect the emitter of this transistor with ground. As we can see, the 5 volt connection is there very near to this ground point. So we'll use a small jumper to transfer this ground point after this 5 volt connection. Here we have moved the ground connection at this position with the help of a jumper. Now we'll connect the emitter of this transistor with ground. Here we have connected the emitter of this transistor with the ground. Now we'll perform the short circuit test. Here we can see the emitter of the transistor is connected with ground. Now we'll perform a short circuit test between ground and 5 volt. Here we can see this resistor is connected with 5 volt. Here we can check this resistor is connected with 5 volt. Now we'll perform a short circuit test between 5 volt and ground. Here we have connected one probe of the multimeter with this resistor, and we'll connect the second probe of the meter with the emitter of the transistor. Here we can check there is no short circuit between 5 volt and ground. Now we'll connect a 2.2k resistor with the base of the transistor, and the second end of the resistor will be connected to port RC4. Here we have a 2.2k resistor. Here we have inserted the 2.2k resistor in Vero board. We have soldered the resistor in Vero board. Now we'll connect the second end of the resistor with port RC4. To complete this connection, we'll place a wire bridge here. Here we have inserted a wire bridge in our Vero board. Now we'll pass the wrapping wire from this bridge. From the schematic we can see that pin number 23 of the microcontroller is port RC4. Here we have connected the second end of 2.2k resistor with pin number 23 of this microcontroller. Now we'll check the continuity of this resistor with pin number 23 of the microcontroller. Here we can check second end of the 2.2k resistor is connected with pin number 23 of the microcontroller, that is port RC4 of the microcontroller. And now we'll connect the freewheeling diode across the coil of this relay. Here we have a diode 1N4M48. We'll use this diode as freewheeling diode in our circuit. Here we have inserted the freewheeling diode in our Vero board. As we have seen from the datasheet that the common point of the relay is here and normally open point is here. So we'll connect a snubber network between normally open and common point of this relay. We'll place 100 ohm resistor here. Here we have inserted a 100 ohm resistor in our circuit. and here we have a 0.1 microfarad 400 volt capacitor. Here we have inserted 0.1 microfarad capacitor in Vero board. We have soldered the resistor and capacitor in our circuit. Now we'll complete the connection for the snubber network. Here we have completed the circuit of snubber network. Now we'll place the green connector to get the output from the relay. Now insert this green connector in Vero board. Here we have inserted the green connector in the Vero board. Now we'll complete the circuit. Here we have soldered the green connector in the Vero board to get the output from the relay. Here we have completed the circuit for one relay, that is relay 1. Now we'll complete the circuit for second relay in the same manner. We have completed the circuit for both the relays. We have wire wrapped the circuit of second relay as we have wire wrapped the circuit of the first relay. Now the control signal of the first relay, that is relay 1, is coming from port RC4 of this microcontroller, and the control signal for the relay 2 is coming from port RC5 of this microcontroller. Now we'll write a program to switch on and switch off the relay with the help of these switches. We'll switch on and switch off this lamp of 220 volts with the help of relays. We'll pass on the 220 volt supply from the contact of this relay and we'll control the status of this lamp.